I want to go through a quick applied quadratic example that'll be perfect for tonight's homework. It's very similar to tonight's homework. And it's a word problem. It says, I'm on a 40-foot tall building. Okay, here's the building. Here I am. And I throw a ball off the building. So here I am throwing the ball off the building with a speed of 15 feet per second. So that means that, how fast did I initially throw the ball off the side. And it can be modeled using the following equation, okay? So we talked about this. This negative 16 relates to gravity. This 15t is the initial speed or velocity. And the plus 40, that's like where I threw the ball from, so above the ground. So I threw it from 40 feet above the ground. All right? So I was throwing the ball upward, okay? So the question is, find the maximum height above the ground that the ball reaches and the time in seconds that it reaches it. So we want, if we look at this graph, a time versus height graph, this is a parabolic equation. We want to look for the max height and what time that height was reached. So this point that we want to really get is the vertex, okay? The ball keeps on gaining in height, okay, until it hits that vertex. That's the turning point. From there on in, it's going down, all right? So we want to know at the vertex, at its pinnacle, what is the height and at what time is that height reached, okay? So we're going to use our equation, x is equal to, or in this case, t, because t is our input value, is equal to negative b over 2a. All right, this is the equation we're going to use. So let's get rid of some of this stuff here. I'll get rid of this drawing. And over here I'm going to put, okay, so we want to find the t is equal to negative b over 2a. That's going to tell us actually the second part, at what time the ball reached its highest height. Okay, so negative b is going to be negative 15 over 2 times a negative 16. And that, if we enter it into our calculators, is 0.46875. Okay? And so that's the time in seconds. So not much after I've thrown it. I threw it at time 0, right? Not too far after I've thrown it, it reached its height, its highest height, okay? Now, how do I find the actual height? Well, this equation up here, you put in a time and it outputs a height. So I know that at 0.468 blah, blah, blah seconds, the ball reached its highest height. So I'm going to plug in that number for t, our input t, and that's going to output our height. So if I do that, I'll just write, I'll write it here and then I'll do it on the calculator. H is equal to negative 16t is this ugly number that we can put into the calculator real easy, plus 15 times that number, plus 40, okay? And the maximum height, it turns out, is, I'll kind of write it up here, is 43.51, or let's say 52 feet, okay? So the highest the ball reaches above the ground is 43 feet. And it reaches it at 0.47 seconds after the ball is thrown. Okay, I hope this helps you on your homework.